An object from the void between stars is currently rampaging through our cosmic neighborhood. They're calling it 3I Atlas, and it's doing something no one saw coming. It's getting brighter, fast, doubling in intensity every few weeks while growing a strange green cloud 500,000 kilometers wide. Astronomers expected a faint flicker. Instead, they got a six-fold surge in brightness that has scrambled all predictions. What is fueling this thing? Is its core hyperactive? Is our sun unlocking alien ices? Let's explore this together. The numbers don't lie. So what do we actually know about this visitor? Let's break down the hard data. Right now, the interstellar comet designated 3I Atlas is roughly 2 astronomical units from the Sun. That's double the distance between the Earth and our star, about 300 million kilometers. Its speed is almost difficult to comprehend. It's currently traveling at nearly 60 kilometers per second and is still accelerating. By the time it makes its closest approach to the Sun, that velocity will peak near 68 kilometers per second. To put that in perspective, that's more than twice the speed of any planet, and fast enough to travel from the Earth to the Moon in a little over an hour. On the brightness scale, 3I Atlas has reached an apparent magnitude of 12. While that's about 250 times too faint for the naked eye, its brightness has been climbing far more rapidly than any models predicted. Its coma, the cloud of gas and dust surrounding the nucleus, has expanded explosively, now rivaling the diameter of Jupiter. While a typical comet nucleus is only a few kilometers across, this expanding atmosphere is what makes it so visible. The sheer scale of this coma is a key reason why it's appearing so much brighter than expected. The unexpected brightness surge. Why is everyone scrambling to get a look at this thing? Because in September, 3I Atlas went completely off script. The light curve the chart astronomers use to track brightness took a sudden sharp turn away from every prediction, a six-fold increase above what the models anticipated. This outburst sparked intense debate among experts like comet specialist Matthew Knight, with some speculating that the nucleus might be fragmenting. The cause seems to be its coma, the massive cloud of gas and dust boiling off its surface. That green cloud has expanded explosively, with recent measurements suggesting it now spans over 500,000 kilometers, meaning if you placed it where the Moon is, it would stretch halfway to the Earth. As this coma grows, it scatters more sunlight, making the entire object appear brighter through our telescopes, even while the solid nucleus stays hidden deep inside. The Atlas team is logging every update and feeding the data to the Minor Planet Center, the official clearinghouse for these observations. This isn't just a comet getting a little brighter, it's a display of activity that is rewriting our expectations for interstellar objects and hinting at a very volatile composition. Racing against the sun's glare. For astronomers on Earth, the clock is ticking. By early October, the window to observe 3I Atlas is closing, and fast. Every evening the comet appears lower in the twilight sky, getting progressively closer to the blinding glare of the sun. The angle between the comet and the sun, what astronomers call solar elongation, will shrink below 30 degrees by October 21st. That's the critical threshold where even the world's most powerful ground-based telescopes, like the Very Large Telescope in Chile, can no longer distinguish the comet's faint glow from the overwhelming brightness of the sky. Amateur astronomy networks are in a frenzy, trying to capture the last possible images before the blackout. Professional observatories, bound by strict safety protocols to protect their sensitive equipment, have already begun to scale back their observations. Pointing a multi-million-dollar telescope too close to the sun is a risk few are willing to take, as it can permanently damage the sensitive optics. This data blackout is happening just as the comet is expected to reach its most active and interesting phase, leaving a huge gap in our understanding. Mars, the last outpost. With Earth-based views about to go dark, the mission to understand 3I Atlas isn't over, it's just changing venues. The focus now shifts to Mars. For a brief period, a fleet of robotic orbiters will have the only front-row seat. The European Space Agency's Mars Express has its high-resolution stereo camera. The ExoMars Trace Gas Orbiter can sniff out faint gases. NASA's MAVEN, under Principal Investigator Shannon Curry, can use its imaging ultraviolet spectrograph to map outgassing and its plasma instruments to watch the solar wind slam into the comet's atmosphere. And the Mars Reconnaissance Orbiter, with its famously sharp HiRISE camera, might even be able to resolve the nucleus itself. The key date is October 3rd, when 3I Atlas flies within 28 million kilometers of Mars. It is an incredible stroke of luck to have so much advanced hardware in the right place at the right time. For weeks, instrument teams have been running simulations and booking precious observation time in a complex, multi-agency effort. This is our last, best chance to get close-up data before the comet swings around the sun and heads back into the interstellar void forever. The green mystery. One of the most captivating features of 3I Atlas is its stunning green glow. What's causing this otherworldly color? Spectral analysis points directly to a molecule called diatomic carbon, or C2. Here's how it works. As the comet gets pummeled by solar radiation, the sunlight breaks apart larger carbon-rich parent molecules on the surface through a process called photodissociation. This process excites the resulting C2 molecules, and as they relax back to a lower energy state, they release photons of light specifically in the green part of the spectrum, primarily in what are known as the swan bands around 510 nanometers. This phenomenon is seen in many comets, but the intensity of the green hue in 3I Atlas is exceptional. The work of Nobel laureate Gerhard Herzberg, who pioneered the study of molecular spectroscopy, provides the foundation for understanding these emissions. This color is a real-time indicator of how rapidly the comet's surface is changing and shedding material as it barrels towards the sun. The impossible anti-tail. Just when you think this comet couldn't get any stranger, observers have reported a feature that seems to defy physics, a faint tail that points towards the sun. This is the opposite of how a comet should behave. This bizarre sunward spike is known as an anti-tail, a phenomenon studied by experts like the late Czech astronomer Zdeněk Sekanina. It's an optical illusion created when Earth passes through the comet's orbital plane. It's formed by larger millimeter-sized dust grains that are too heavy to be pushed away by solar radiation, and instead get left behind along the comet's path like breadcrumbs. From our perspective, this trailing debris field looks like a spike aimed at the sun. For comparison, the famous comet Aaron-Rowland in 1957 displayed a stunning, easily visible anti-tail. Confirming this feature on an interstellar object would be a major discovery, providing invaluable clues about the size and density of its dust particles, information that is otherwise impossible to obtain from millions of kilometers away. It would tell us if the pebbles that built this alien object are different from our own. Not like the others. To truly understand how unusual 3I Atlas is, we have to compare it to the only other interstellar visitors we've ever seen. The first, 1I Oumuamua, discovered in 2017, was a bizarre, cigar-shaped object with a high orbital eccentricity of 1.20 and no visible coma or tail. It was a dry, inert shard tumbling through our solar system. Then, 2 years later, 2I Borisov arrived, and it looked much more like a classic comet, with an even higher eccentricity of 3.3. It had a bright coma, a well-defined dust tail, and a chemical makeup similar to comets from our own Oort cloud. But, 3I Atlas refuses to fit into either of these boxes. Its coma is not only massive but also intensely green, a sign of strong diatomic carbon emission not seen with such intensity in Borisov. Its dramatic brightness surge, a 6-fold increase above predictions, is unlike anything seen with the other two. According to University of Hawaii astronomer Karen Meach, this diversity shows we have much to learn about the small body populations of other star systems. The Mars encounter strategy. So, what is the game plan for the Mars flyby? It's a massive technical challenge. The various science teams have been working for weeks to prepare, running simulations and negotiating for priority access in a complex effort between NASA and ESA. The ultimate prize would be to visually resolve the nucleus, to see the solid body at the heart of the glowing cloud, and look for jets of outgassing material. This is incredibly difficult due to the spacecraft's slewing rates, or how fast they can turn to track a moving target. Another key goal is to measure the deuterium to hydrogen ratio in its water vapor, a crucial clue to where and when it formed in its home star system. Even the data downlink is a challenge, as it will take up to 20 minutes for the signals to travel from Mars back to Earth, and bandwidth is limited. A single high-resolution image could take hours to transmit. Even with the best planning, the encounter is a high-risk, high-reward gamble on an object that remains utterly unpredictable. Chemistry in motion. Let's dive deeper into the chemistry that makes 3I Atlas so fascinating. The dominant green glow comes from diatomic carbon. But it's not the only molecule at play. Some early spectral readings have hinted at the presence of ionized carbon monoxide and the cyanogen radical, both of which can also contribute to a green or blue glow. Debates have already started in scientific forums about the precise mix of these chemicals, often relying on data from powerful spectrographs like the X-shooter instrument on the VLT, which can cover wavelengths from the ultraviolet to the near-infrared in a single shot. The comet's incredible speed is a key factor here. It means that solar radiation is stripping away fresh, pristine ices from the nucleus at an astonishing rate. We are not just seeing ancient processed material from the surface, we are likely getting a look at the primordial parent molecules that were frozen inside this object when it formed billions of years ago in a completely different planetary system. This makes 3I Atlas a unique chemical laboratory. The fade begins. After 3I Atlas swings around the sun, its spectacular show will likely come to a quick end. As it speeds away from the sun's heat, most models predict its brightness will plummet, perhaps even faster than it rose. For anyone still hoping to track it, you'll need a telescope with at least a 20-centimeter mirror and a sensitive digital camera using long exposures. The focus will then shift to citizen science networks like the Interstellar network and Zooniverse, which will collect observations from dedicated amateurs. This amateur data is invaluable for long-term monitoring, as professional observatories with limited funding can't afford to spend weeks tracking a single fading object. These global networks will watch for post-perihelion outbursts or changes in the coma's shape, providing crucial data on how the comet shuts down after its violent encounter. It will be the collective work of thousands of skywatchers that writes the final chapter of this object's visit, ensuring its legacy is captured before it disappears into the dark. The journey of 3I Atlas through our solar system, though brief, leaves us with more questions than answers. Each data point gathered from this mysterious visitor helps us understand the diversity of objects that wander the galaxy. What does its unique composition tell us about the planetary system where it was born? How many more of these interstellar travelers are out there, waiting to be discovered? As it slips back into the darkness, 3I Atlas reminds us that our solar system is not an island, but part of a vast interconnected cosmos. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our universe. Thank you for watching Space Facts.